Hello! Today we're going to learn about two important classes of organic compounds called alcohols and ethers. These compounds are structurally similar, but they have different functional groups that give them unique properties and behaviors. An alcohol is an organic compound that contains a hydroxyl group, which is an oxygen atom bonded to a hydrogen atom written as -OH. This hydroxyl group is attached to a carbon atom in a molecule, written here in this example. For example, if there's a 3-carbon chain with a hydroxyl group on the first carbon, we call it propan-1-ol. The presence of a hydroxyl group makes alcohols polar because oxygen is more electronegative than carbon or hydrogen. This polarity has important effects on the properties of alcohols. For example, alcohols can form hydrogen bonds with each other and with water molecules. Hydrogen bonding increases the boiling point of alcohols compared to non-polar hydrocarbons of similar size. It also makes lower molecule weight alcohols soluble in water. Now, let's talk about ethers. An ether is an organic compound where an oxygen atom is bonded to two carbon-containing groups, which we often write as ROR. In ethers, the oxygen is bonded to two alkyl groups with single bonds. Ethers are named by identifying the two groups attached to oxygen and adding the prefix oxy. For example, ethoxyethane right here has two ethyl groups on either side of the oxygen. Ethers are generally less polar than alcohols because they do not have an OH group. As a result, ethers do not hydrogen bond with themselves, though they can accept hydrogen bonds from molecules like water. This means that ethers typically have lower boiling points than similar alcohols, and they are often used as relatively stable organic solvents. Now, both alcohols and ethers are considered functional groups in organic chemistry. A functional group is a specific argument of atoms that gives a molecule particular characteristics and reactivity patterns. Because alcohols contain a hydroxyl group and ethers contain oxygen between two carbon groups, they react differently in chemical reactions and behave differently in solutions. Let's summarize the key differences. Alcohols contain an OH group that can form hydrogen bonds, which leads to higher boiling points and greater solubility in water for small alcohols. In contrast, ethers can contain an oxygen bonded to two carbon groups, ROR, which means they are less able to do hydrogen bonds with themselves, resulting in lower boiling points and often moderate solubility in water. Another important point is that alcohols and ethers with the same molecular formula can be functional isomers. This means they have the same number and type of atoms, but the atoms are connected in different ways, leading to different properties. For example, butan-1-ol and ethoxyethane both share C4H10O as their formula, but one is an alcohol and one is an ether. Now, understanding alcohols and ethers is important because these groups appear in many real-world substances. Alcohols like ethanol are found in beverages, fuels, and solvents. Ethers such as diethyl ether have historically been used as anesthesics and organic solvents in laboratories. Their structures and properties explain how they behave in chemical reactions and mixtures. Anyways, that was a basic lesson on alcohols and ethers. By the end of this lesson, you should know the basic skills of naming different alcohols and ethers, understanding the properties of the functional groups, and understand the topic of functional isomers. I hope you enjoyed this video. The next lesson for today will be on the great Le Chatelier's principle. I'll see you in the next lesson. Bye-bye.
This has been a Matthew Thomas production. Ka-chow!